Hello everybody, welcome into another lesson. So today we are going to talk about doing adding and subtracting operations with radical variable expressions. So a fairly straightforward one. We have 2 times the fifth root of y plus 7 times the fifth root of y. Same base, same root, so we can treat that fifth root of y like a normal variable. So just add the coefficients, you'll literally get 9 times the fifth root of y. And that would be your answer, would be 9 times the fifth root of y. Easy peasy lemon squeezy. Alright, I have about 5 more. Now we have 9x to the 1/5 minus 2x to the 1/5. Well, 9x to the 1/5 minus 2x to the 1/5, same base, same power, so you just subtract the coefficients. You would end up getting 7x to the 1/5, which could also be rewritten as 7 times the fifth root of x. Pretty simple. Alright, let's see. We have negative of the fourth root of x plus 2 times the fourth root of x. So, negative of the fourth root of x plus 2 times the fourth root of x. Well, same base, same roots, so you just add the coefficients. You would just literally end up getting the fourth root of x. That would be your answer, the fourth root of x. I have 3 more, but they're going to get a little bit trickier. Now, we have x to the 9th y raised to the 1/3 power plus x y to the 1/9 raised to the 3rd power. So it looks like we have definitely same bases but different exponents, but we'll just have to perform the exponent operations. So your first term, x to the 9th times 1/3, that would simply be x to the 3rd. Y times 1 to the 1/3, well, that would just be y to the 1/3. Plus, let's deal with your second term. X to the 3rd, that would be x to the 3rd. Excuse me. Y to the 1/9 times 3, that would be y to the 1/3. Now you have it where they're the same bases and same exponents, so add your coefficients together. This would end up giving you 2x to the 3rd, y to the 1/3, which would simplify into 2x to the 3rd cube root of y. You could write it in either form. This would simplify into 2x to the 3rd cube root of y. Two more. Alright. Square root of 4x to the 5th minus x times the cube root of x. I'm sorry, that's the cube root of x to the 3rd. Okay. Sorry, the square root of x to the 3rd. Boy, I don't know where I'm pulling the cube root from. Let's look at these two terms individually here, okay? So, the first term, of course, you have the square root of 4. Now that x to the 5th could be split into the square root of x to the 4th times the square root of x, right? There's a reason I'm doing this. Minus, now your second term, you have x, then that square root of x to the 3rd, that could be split into the square root of x squared times the square root of x. Now let's simplify each term. What's the square root of 4? Well, that's going to be 2. What's the square root of x to the 4th? That'd be x squared. Square root of x, there's really nothing we can do with that. Minus, now, what is the square root of x squared? That'd be x, so x times x is x squared. Then you just have that free-floating square root of x. Now notice you have the same bases and same roots, so we just got to subtract the coefficients. So this will just turn into x squared times the square root of x. That's the best we could do with that. You'll end up getting x squared times the square root of x. I got one more. Y times the cube root of 24 x to the 5th plus the cube root of negative 3 x squared y to the 3rd. All right, so we have y times the cube root of 24 x to the 5th plus the cube root of negative 3 x to the 2nd y to the 3rd. Well, let's look at each of these terms individually again. So you'll have, for your first term, you have y. Now, 24 is not a perfect cube, but are any of its factors a perfect cube? Actually, yes. 8, if you do 8 and 3, you'll have y times the cube root of 8 times the cube root of 3. And then x to the 5th, that could be split into the cube root of x to the 3rd times the cube root of x to the 2nd. That's all your first term. Plus, let's look at all your second term. All right, so negative 3, here's the thing. Negative 1's a perfect cube, right? This could split into the cube root of negative 1 times the cube root of 3, because odd roots are defined for all real numbers. Now, of course, you'll have the cube root of x to the 2nd, which we can't do anything with. Then you'll have the cube root of y to the 3rd. So yes, I know this looks like a hot mess, but it's all going to make sense in a minute. So y you can't do anything with, but what's the cube root of 8? That's 2, so you have y times 2. Then that cube root of 3, there's really nothing we can do with that. Cube root of x to the 3rd, that's just x. Cube root of x squared, there's really nothing we can do with that. So we've simplified this a little bit, plus, what is the cube root of negative 1? Well, that's just negative 1. Then you'll have times the cube root of 3, which we can't do anything with, times the cube root of x squared, which we can't do anything with. But what's the cube root of y to the 3rd? Well, that's just y. So let's simplify a bit further. Take everything outside the radicals. You'll end up with 2xy times the cube root of 3x squared. The second term, you'd have minus y times the cube root of 3x squared. Well, it would almost look like we can simplify this further, but notice the second term doesn't have an x. Unfortunately, this is as far as we can go. If the second term had an x to the first, we could subtract coefficients, but it doesn't. So this is as far as we can go with this. You'll end up getting 2xy times the cube root of 3x squared minus y times the cube root of 3x squared. And that's as far as you can go. So that's it for this lesson. Next lesson, we'll apply these properties to irrational exponents. So I hope everyone has a great day. Take care.